students, welcome to the lecture on facility planning process and layout. And after this lecture, we'll be able to learn the following objectives. Explain the concept of facility plan. Understand the objectives of facility plan. Define the facilities planning process. Understand the facility layouts. Explain the designing, preparing a facility layout. Explain the computerized relative allocation of facilities technique, CRAFT. Let's start with the introduction of facility planning process and layout. Whenever an existing facility is renovated or a new facility designed, the chance exists to develop a layout that will improve process flow and minimize wasted space. When a new facility is designed, the facility layout should be integrated into the architectural design. Limitations on building lot size and shape, however, may heavily influence the layout configurations available. In other situations, a new layout is achieved simply by renovating an existing area, in which case the size and shape of the area are set, and the limitations relate to the funds available. Planning facility layout is important for many reasons. The amount of capital invested in new construction or renovation is usually substantial. The results are long-term. While minor modifications may be possible, the overall layout will last well into the future. Furthermore, layout has an enormous effect on daily operations. Not only does layout dictate the distance a patient must travel from one department to another, it also influences which staff members are likely to interact and communicate. The amount of space allocated to a given department often is set by factors beyond the control of the facility planner, whose job it then is to make the most of that space. A poorly designed workspace harms both productivity and quality. Another aspect, the travel distance between departments, is a cost that can reach enormous proportions long-term. What may seem a short walk to a designer may add up. Over the life of a facility, 2 days lost to travel. Let us now discuss the concept of facility plan. Facility planning is an emerging field with confusing terminology. How does a master plan differ from a strategic master plan? Is a campus plan part of a master plan or something else? Every architect, consultant, and builder defines these terms differently.
The Imagine Great Schools Facilities Master Plan was developed to provide a roadmap for the district to review its facilities, determine necessary right-sizing adjustments, and help guide where future investments need to be made. Phase 1 of the master plan is complete. Since November, we have been analyzing current and historical data to determine how our district can transform into a system of quality schools that promote high student achievement in the most equitable and cost-effective manner. The research conducted in Phase 1 brought attention to the steady decline of enrollment and overwhelming number of empty seats in district-operated schools. In response to these statistics, we have identified 4 critical actions to occur in Phase 2. The first action of Phase 2 will be to review educational programs to identify inequities and disparity. From there, we can develop a strategy for future program delivery supported by academic rationale and data. Step 2 will be to begin reducing the number of empty seats through building closures, program consolidations, and co-location. Step 3 will be to develop a future capital program that addresses deferred maintenance in existing district facilities, and in Step 4, we will determine a plan for surplus real estate and opportunity for community engagement. The actions in Phase 2 will create opportunity for program enhancement. With better populated schools, we can provide better academics programs and extracurricular opportunities for students. Resource efficiencies that will better utilize staff and specialists to support social services for students. program realignment that can repurpose available resources for emerging and unique programs of study. And finally, service alignment that will improve maintenance, prioritize expenditures, and revise transportation services.
Master plan. A master plan, or facility master plan, or campus master plan, is a long-term schedule of projects based only on assumptions provided by executives. A master plan can have very different levels of detail and usually includes some or all of these space use analysis, assessment of zoning regulations covenants, description of space standards benchmarks, program of space use, workflow analysis. Strategic facility plan. A strategic facility plan builds on a master plan by adding strategic analysis of what is driving the projects. It does not depend only on the manager's assumptions. These analyses might be of market, labor, and transport geographies, operations and logistics, brand assessment, IT plan. Did you know? The European Facility Management Association, EuroFM, uses the EN 15221 definition. The definition of facility management, EN 15221-1, provided by the European Committee for Standardization, CEN, and ratified by 31 European countries, is the integration of processes within an organization to maintain and develop the agreed services which support and improve the effectiveness of its primary activities. Now we will study the objectives of facility planning. Facilities planning must be done within the context of the supply chain to maintain a strategic competitive advantage. Just as supply chain synthesis is driven by customer satisfaction, so too should customer satisfaction be the primary objective of facilities planning. This will ensure that the other objectives are in alignment with what drives the enterprise, namely revenues and profits from customers. Many entities lose sight of the importance their customers have to their existence. Looking at customers as an internal element of the supply chain allows the focus to sustain itself indefinitely. Too many companies, governmental agencies, educational institutions, and services become so focused on the other internal elements and issues that the primary end customer focus is lost. The facilities planning objectives are to improve customer satisfaction by being easy to do business with, conforming to customer promises and responding to customer needs. Increase return on assets, ROA, by maximizing inventory turns, minimizing obsolete inventory, maximizing employee participation, and maximizing continuous improvement. Maximize speed for quick customer response. Reduce costs and grow the supply chain profitability. Let's now understand the facilities planning process. The facilities planning process is best understood by placing it in the context of a facility life cycle. Although a facility is planned only once, it is frequently deplanned to synchronize the facility and its constantly changing objectives. This process continues until a facility is torn down. The facility is continuously improved to satisfy its constantly changing objectives. Define the problem. Define or redefine the objective of the facility, whether planning a new facility or the improvement of an existing facility. Analyze the problem. Determine the interrelationships among all activities. Establish whether or how activities interact with or support one another within the boundaries of the facility and how this is to be undertaken. Determine the space requirements for all activities. All equipment, material, and personal requirements must be considered when calculating space requirements for each activity. Generate alternative designs. Generate alternative facilities plans. The alternative facilities plans will include both alternative facilities locations and alternative designs for die facility. Evaluate the alternatives. Evaluate alternative facilities plans. On the basis of accepted criteria, rank the plans specified. Select the preferred design. Select the facilities plan. The problem is to determine which plan, if any, will be the most acceptable in satisfying the goals and objectives of the organization. A typical manufacturing plant has a number of diverse activities interacting with each other. Thus, raw materials arrive at a shipping dock. They are unpacked and checked in a quality control area. They may then be processed through several processing areas, and finally the finished product again passes through the shipping dock. In addition to areas specifically related to production, there must be dressing rooms, lunch rooms, and restrooms for employees, offices for supervision, design, and production control, and space for inventory and aisles. In fact, a plant may be viewed as a large number of finite geometric areas arranged on the floor space of the building. The problem of arranging these areas in an effective manner is the facility layout problem.
Hi, welcome to Chapter 6, Process Design and Facility Layout. This is video number 2. In the first video we looked at assembly line balancing. In this one we're going to look at facility layout. And here's the idea. We have 3 physical regions of our plant. We'll call them A, B, and C. And there's some distance between them. I don't know if they're actually physically arranged like this, but there are distances between them and we can measure those. We also have 3 departments. We'll call them 1, 2, and 3. And product flows from 1 to 2. It also flows from 2 back to 1. And as it turns out, when we see the numbers, we have twice as much product flowing this way as flowing this way. And how do we take these departments and assign them to these locations? To do so in a cost minimizing fashion. So that's what we're interested in doing. So we're trying to design a process layout to minimize the transportation total cost. This is example 10 from the textbook. So the first thing we have are distances between our locations. From location A to location B is 20 units of measure, whatever it is, meters might be. And likewise from B to A is 20 meters. So they're symmetrical. So we could draw a line down the diagonal here, and actually you could ignore these values underneath because the values down here are the same as the values above the diagonal. So often you'll see only half the matrix filled in because it's symmetrical. We also assume that movement within the department is a distance of 0. So that's table 6.4 in the textbook. So we have our distances between the physical spaces of our plants. The next thing we have are the number of loads per day between the different departments. Now this isn't symmetrical, so you can see product moving from department 1 to department 2, there's 10 loads a day, but from department 2 going into department 1, there's 20 loads a day. So it's not symmetrical, but that's okay. Maybe you're taking a large box and you're breaking it down into a number of smaller pieces and transporting them around. One thing you should take note of, though, is where we incur the most number of loads per day. So here, from department 3 going into 1, we have 90, and in fact from 1 going into 3, we have 80. So between these 2 departments, between department 1 and department 3, we have 170 units being shipped back and forth between them. That would tell me that I want departments 1 and department 3 to be located close to each other. Now what does close mean? Well, we can go back to our distances and we can see that the smallest distance here is between A and B. So we could just jot down, let's put 1 in A and 3 in B, say. And then we can go back to our table. Where do we incur the next most amount of work? Well, from 3 going into 2 is 70 loads a day, and from 2 into 3, right here, is 30. So between departments 2 and 3, we have 100 loads, and we want those to be fairly close together. So if we were to put, those are close together, they have a high load. If we were to put department 2 over here, for example, then the distance from B to C is the next highest, which is 30. And conversely, the lowest number of loads per day, this total here, is 30 units, 30 loads per day, and maybe we could make that travel the most amount of distance. So from A to C, from 1 to 2. So that's one way you can assign that. In fact, that's the way this heuristic works. If we look at the solution from the textbook, that's exactly what happened here. This is location A, it got assigned department 1. Location B got assigned department 3. There was 170 units or loads going back and forth between these two. And likewise between these guys here was 100. And then not much traffic between 1 and 2, only 30, so we have C over here. If we want to calculate the actual cost, that's easy to do. Again, we just take the information that we have. This is right from the tables 6.4 and 6.5. So department 1 to department 2, 10 loads a day. Department 1's in location A, department 2's in location C. The distance between them is 40. 10 loads times 40 gives me a total of 400. And it turns out to be $1 per meter, I guess, in this example. So this just is $400. And you can do the same thing. From 3 to 2, there's 70 loads a day. The distance traveled is 30. That's 2,100. And with the multiplier of 1 gives us $2,100. The total cost of this arrangement is $7,600. So that was example 10 in a nutshell. Again, from chapter 6, process layout, or process design and facility layout.
Types of layouts. There are several alternative layout types that are appropriate for different product mixes and production volumes. Determination of the layout type is a major design decision because it impacts on so many other aspects of the production system. Process layout. Process layout are established mainly in occupation shops or firms that produce modified, short sound goods which may need dissimilar giving out desires and progressions. Process layouts are service patterns in which processes of a comparable nature or function are set mutually. Services which employ process layouts comprise hospitals, banks, auto repair, libraries, and universities. Recovering process layout engages the reduction of transportation charge, detachment, or occasion. Facts of process layout. The process layout is a supple layout outstanding for short to average manufacture amount. It is exceptional for middle to lofty production dissimilarity. Advantages of process layout. The process layout gives a lithness, which means the firm has the skill to grip a multiplicity of dispensation desires. Then it helps in cost. Every so often, the common reason tools used perhaps not as much expensive to acquire and easier to preserve than dedicated. Product layout. Two types of lines are used in product layouts, paced and unpaced. Paced lines can use some sort of conveyor that moves output along at a continuous rate so that workers can perform operations on the product as it goes by. For longer operating times, the worker may have to walk alongside the work as it moves until he or she is finished and can walk back to the workstation to begin working on another part. This essentially is how automobile manufacturing works. Advantages of product layouts include output. Product layouts can generate a large volume of products in a short time. Cost. Unit cost is low as a result of the high volume. Labor specialization results in reduced training time and cost. A wider span of supervision also reduces labor costs. Accounting, purchasing, and inventory control are routine. Because routing is fixed, less attention is required. Fixed position layout. A fixed position layout is appropriate for a product that is too large or too heavy to move. For example, battleships are not produced on an assembly line. Cellular layout. Cellular manufacturing is a type of layout where machines are grouped according to the process requirements for a set of similar items that require similar processing. These groups are called cells. Therefore, a cellular layout is an equipment layout configured to support cellular manufacturing. Did you know? The FM sector acts as an umbrella, horizontally oriented market. It currently represents about 5% of global GDP. Because of its increasing relevance to the core business, it more and more takes the lead when developing a new world of work and new ways of working. Facility layout and design is an important component of a business's overall operations, both in terms of maximizing the effectiveness of the production process and meeting the needs of employees. The basic objective of layout is to ensure a smooth flow of work, material, and information through a system. The basic meaning of facility is the space in which a business's activities take place. Factors in determining layout and design. Small business owners need to consider many operational factors when building or renovating a facility for maximum layout effectiveness. These criteria include ease of future expansion or change. Facilities should be designed so that they can be easily expanded or adjusted to meet changing production needs. Although redesigning a facility is a major, expensive undertaking not to be done lightly, there is always the possibility that a redesign will be necessary. Therefore, any design should be flexible. Flexible manufacturing systems most often are highly automated facilities having intermediate volume production of a variety of products. Their goal is to minimize changeover or setup times for producing the different products while still achieving close to assembly line single product production rates. Differences between office and factory layouts. Offices and manufacturing facilities are typically designed in much different ways, a reflection of the disparate products that the two entities make. A factory produces things, wrote Stephen Kuntz in Facility Design. These things are moved with conveyors and lift trucks. Factory utilities include gas, water, compressed air, waste disposal, and large amounts of power as well as telephones and computer networks. A layout criterion is minimization of transportation cost. Layout requirements can also differ dramatically by industry. The needs of service-oriented businesses, for instance, are often predicated on whether customers receive their services at the physical location of the business, such as a bank or pet grooming shop, for instance, or whether the business goes to the customer's home or place of business to provide the service, as with exterminators, home repair businesses, plumbing services, etc. Several computer programs can generate the initial possible layouts using both from-to chart method and the closeness rating chart. Some of these programs also allow the user to consider travel costs associated with movement between different departments. Most of the programs start with departments in random positions, calculate some relative cost measure, and then move departments in pairs or triplets until the layout with a lower relative cost is found. It is important to note that depending on which method is used, some programs may not necessarily generate an optimal solution. Although computer programs generate only an initial layout from which to start, it is an excellent sharing point that may lead to a layout that might not otherwise have been developed. A number of computerized layout programs have been developed since the 1970s to help devise good process layouts. Of these, the most widely applied is the Computerized Relative Allocation of Facilities technique, CRAFT. The CRAFT method follows the same basic idea that we developed in the layout of the toy factory, but with some significant operational differences. Like the toy factory example, it requires a load matrix and a distance matrix as initial inputs. But in addition, it requires a cost per unit distance traveled, say INR 50 per foot moved. With these inputs and an initial layout in the program, CRAFT then tries to improve the relative placement of the departments as measured by total material handling cost for the layout. Material handling costs between departments equal number of loads multiplied by rectilinear distance between department centroids multiplied by cost per unit distance. It makes improvements by exchanging pairs of departments iteratively until no further cost reductions are possible. That is, the program calculates the effect on total cost of exchanging departments. If this yields a reduction, the exchange is made, which constitutes iteration. Distinguishing features of CRAFT. Features of CRAFT and issues relating to it are: it is a heuristic program. It uses a simple rule of thumb in making evaluations. Compare two departments at a time and exchange them if it reduces the total cost of the layout. This type of rule is obviously necessary to analyze even a modest-sized layout. It does not guarantee an optimal solution. Now, in the end, let us summarize what we have learned in this lecture. Capital facilities planning are a key component in a community's comprehensive plan. The capital facilities plan ensures there are adequate level of facilities and services in place to support development at a time of occupancy or use. The master plan can be summarized as a color site drawing or a timeline of projects. Sometimes the drawing itself is referred to as the master plan. A strategic facility plan builds on a master plan by adding strategic analysis of what is driving the projects. The CRAFT method follows the same basic idea that we developed in the layout of the toy factory, but with some significant operational differences. The second phase of the facilities planning process is assessing the present status, identifying specific goals, identifying alternative approaches, evaluating alternative approaches, defining improvement plans, and obtaining support for improvement. The process layout is otherwise called as functional layout or job shop layout. Process layout engages assembling mutually in one section base leading their operational kind.